Alright, I am now going to go ahead and show you how to find the volume of a cylinder. Okay, you're going to notice that the volume of a cylinder is base time area of the base times the height, which looks just like that of a prism. And that is, I mean, it's pretty much the same thing. You can see how a prism and a cylinder, they share the same formula. Big B times H, where again, big B stands for area of the base. And this is where it differentiates. So again, big B stands for area of base, but because my base happens to be a circle, it's going to be the area of a circle. Again, that's what's going to make this different. So when we're going to calculate this, we're going to be using pi r squared. That's the only difference. Your height is still the distance between your bases. So my bases are these circles right here. And the distance between them, in this case the 6, that is my height. So let's say we have to solve this, right? All you need is two values, your radius and your height. Because this formula becomes pi r squared times height. So again, you only need to know your r and your h in a cylinder. Cylinders, again, are one of the easier shapes to work with whenever you're solving for volume or surface areas, because it's just two variables. So my height is 6, and my radius is not 10, it is 5, right? It is 5, yeah, because that 10, notice where it's going, from where to where, it represents our diameter. Alright, so now we just have to substitute, and that's it. So volume is simply the volume of my figure is going to be my pi times my radius, which is 5, squared times my height, which is 6. I'm just going to come here and I'm going to use my calculator, and literally I just put pi times 5 squared times 6. And so the volume of this cylinder is 471.2 units cubed, whatever they be. Let's just say that the units were, I guess, millimeters, right? So this would be millimeters cubed. And volume represents the stuff inside. So in this can, this tomato can here, they're telling me the weight is 8 ounces. Okay. There should be somewhere here that talks about serving size. Alright, so there's about 3.5 serving sizes per container, and there's 1/4 a cup for each. So 1/4 times 3.5. So this has a little bit under a cup's worth of volume. But anyways, volume again is the space inside. That's how easy it is to find the cylinder, guys. A few more examples. What if you have to find an unknown value? So here we go. What if they already told you, hey, the volume is 500, find me the radius? Again, it is given that the volume is 500 centimeters cubed. Let's just say that these 10 was centimeters as well. The height is 10 centimeters as well. Remember that volume is just big B times h, which translates in a cylinder to pi r squared times h. We're going to substitute all our known values. So this becomes 500 is equal to pi. Remember how we're just multiplying here, so I'm just going to put the h right in front. Pi times 10 times my radius squared. And again, go back and check everything's accounted for. The v is accounted for, the pi is accounted for, the h is accounted for, and the r squared is accounted for. Now it's just inverse operations. Again, basically to leave r squared by itself, I have to divide. But for those of you guys that don't have one of those fancy calculators that could simply say 500 divided by pi times 10, I would recommend just, well, what is 10 times pi? And it'll make it easier for you. So this becomes 500 is equal to 31.4 times r squared. And so we just have to divide, right? We divide both sides by the 31.4 to isolate the r squared. So 500 divided by 31.4. And so now I find out that this becomes 15.92 is what r squared is. Remember that to get rid of the square, we do the inverse, which is a square root. So we calculate the square root of 15.9. And whatever I get, that is what r will be. And a lot of you guys could probably already, guess what the approximate answer is, because 15.9 is really close to 16. And notice how the answer is 3.98. So we could pretty much say that our radius is just 4. This is perhaps the harder problem in a cylinder, just because you have to do a square root in the end. Not too bad. Okay, again, everything that was given, I wrote it down, I substituted, and I just did algebra. That was it. Okay, now what if you have to find the height? Well, this one's a lot easier. You don't even need to draw a picture, guys. But right off the bat, they're telling us that this is a cylinder. So because it's a cylinder and we're talking about volume, you write down the formula. All right, so again, now we substitute everything we know. They're telling us that the volume is 1,000 meters cubed and that the radius is 20 meters. Again, they're the same units, so we don't have to worry about conversions. So 1,000 must be equal to, oh, I forgot the h here. Again, this is just b, 5 times h. So 1,000 is equal to my pi times my radius squared times my height, but I don't know my height. And again, at this point, it really is just moving this to the other side through division. But for those of you guys that don't have a calculator that could do it all at once, I would recommend just finding out what that is. So pi times 20 squared. So this becomes 1,000 is equal to 1,256.64 times h. And again, it's just division. So 1,000 divided by that. Oops. So get the same answer here. And I get that I have to divide. Whatever you do to one side, you must do it to the other. My height is 0.79 meters, which, if you wanted to, you could say that your height was 0.8 meters. Again, sometimes you have to work backwards, but that is all it is, guys.